took notes over inverses, I did use my graphing calculator, and I kind of gave you a sneak peek as to what the sine and cosine graphs look like. Okay? You maybe remember that, you maybe don't. It's not a big deal. But I want to talk about how these graphs are built and the features that they have. Okay? Now, for the first 5 minutes of notes, you can just kind of sit there and watch. Okay? There's probably, in the first 5 to 7 minutes of what we do up here, there's 2 things I'm going to have you write down. All right? So just go along with me here. Let's think about the unit circle. Okay? If I want to come up with y equals the sine of x, we input angles into the sine function, and our outputs will be ratios. Okay? So when we rotate around the unit circle, the sine of 0 is 0. The sine of 30, or pi over 6, is 1/2. At pi over 4, it's radical 2 over 2. At pi over 3, it's radical 3 over 2. And at pi over 2, it's 1. The sine of pi over 2 is 1. So graphically, we would have a coordinate at pi over 2, 1. Okay? Then, as we rotate around the unit circle, what happens to our sine values? They drop back down to where at pi, we're at 0, right? And then what happens with our sine values? Now we go in the negative direction. The sine of 3 pi over 2 is -1. And then we climb back up until the sine of 2 pi is back to 0. Okay? I have this little animation that I'd like to show you. Okay? Okay. Watch this right here. As we go around the unit circle, it's plotting those xy coordinates. Now there's more than 16 angles on the unit circle. That's just all we talk about. Okay? So the sine of 0 is 0. The sine of pi over 2 is 1, so there's that coordinate. The sine of pi is 0. There's the x-axis. The sine of 3 pi over 2 is -1. So here's that coordinate right there. And then it makes it back. Okay? Now, if we keep rotating around and around, 0 to 2 pi, to 4 pi, to 6 pi, I mean, we can just keep rotating and rotating and rotating. Then we get this squiggle that happens over and over and over again. Okay? Those of you who have worked with sound waves, you've maybe seen some of these patterns in physics. All right? But this is our sine curve. Okay? It's going to go on forever, repeatedly, in both directions. Okay? But what I'm concerned about, I want you to be able to recognize just one chunk of the graph. Okay? So I am going to have you draw this red highlighted piece of the graph in your notebook. Okay? There's 5 coordinates, and make sure we have these labels there. Okay? But this is the parent function for y equals the sine of x. It's going to repeat that S shape over and over and over, but that piece in red is one unique chunk of it that we're going to focus on. some similar values. Not at the angle, but their ratios, they have some things in common. Right? So let's talk about y equals the cosine of x. If I go around the unit circle and we highlight all of the cosine ratios, the cosine of 0 is 1. And then we drop down until the cosine of pi over 2 is 0. So we start at 1, we drop to 0, and then we go in the negative direction all the way until the cosine of pi is negative 1. And then as we rotate back, we have negative ratios for cosine all the way until we get covering it, but the cosine of 3 pi over 2 is 0, and then we climb back up until the cosine of 2 pi is 1. All right, so I have an animation for the cosine curve now. Okay, so as we, it's like there's a line. There we go. As we go around the unit circle and grab all of those coordinates, remember the input, the x coordinates are the angles, the y coordinates are what the cosine values actually are. The cosine of 0 is 1, the cosine of pi over 2 is 0, the cosine of pi is negative 1, so there's that coordinate right there. The cosine of 3 pi over 2 is 0, and then the cosine of 2 pi, we're back to 1. Okay, now if we continue to go round and around and around the unit circle, we get that same wave. It just starts at a different place. So you can see how they look like the same shape, just kind of shifted from each other. All right, but this is what I'm going to be concerned about here, this one unique chunk of the cosine curve. So that's what I'm going to have you draw when we get to here. All right. So here is the cosine curve, and it goes on forever in both directions, but I'm going to have you draw that red highlighted piece. That's what we call one period of the curve. It's a unique chunk. So we're going to actually graph these on Monday, but what I want to make sure that we understand today are some of the features of the graph and how our equations could affect our graph. So in chapter 1, we talked a lot about transformations, right? Stretches and shrinks and shifts. So we're going to talk about the same thing here with these sine and cosine graphs. They're going to be a little bit different in the fact that we have some vocabulary to focus on with them. All right, but our numbers are still going to affect our equations the same, whether they're outside or inside the function. Stretches, shrinks, shifts, they all are the same from what we learned in chapter 1. But let's get some vocabulary attached to these. Okay? Amplitude is the first word. Amplitude, what does that make you think of? Sound. Okay, what specifically about the sound?
It's waves.
It's waves. Okay, like the sound waves. All right, so when we're talking about the amplitude of a sine or cosine function, okay, answer me this. If sound is quiet, what's true about the sound waves? Are they like short, right? And if sound is loud, then the sound waves are tall. Okay, so depending on the amplitude, it will affect the height of our waves. So amplitude is referring to how tall our waves are, okay? And we pick out the amplitude by half of the vertical distance from highest to lowest point. I'll have you write that down and we'll go back to our curve so we can pick out what the amplitude would be of the ones we drew. Okay, so let's come over here. I'm going to start with the sine graph. If we were to look at the distance between the highest and lowest point, here's our lowest point at -1. Here's our highest point at +1. What's the total vertical distance? What would the distance be? Like how far apart are those 2 points? 2. Yeah. So our amplitude would be half the vertical distance. So it would be 1. Same thing with y equals the cosine of x. Our parent graph, our lowest point's at -1, our highest point's at +1. So the total vertical distance is 2, which makes this graph have an amplitude of 1 also. All right, so the amplitude refers to our vertical height of the curve. What do you think the period will refer to? Length, okay? So we talked about how the sine and cosine curve, they repeat over and over and over and over and over again. The period is going to refer to the horizontal distance between a point on the graph and a point where it starts to repeat itself. So how long horizontally is our curve before it starts to repeat? Let's see. So if we come over here to the sine curve, I have highlighted one period, all right? Here we have a coordinate at 0, 0. We make this S shape, and here at 2 pi 0, that shape begins again. So this horizontal distance stretches from 0 to 2 pi. So the period of this parent graph is 2 pi. Same thing then with our cosine parent function. We start up here on a hill at 0, 1. We drop down into the valley and we come back up and it starts to repeat that valley here. So from 0 to 2 pi, we have a unique chunk of the graph before it starts to repeat. So this also has a period of 2 pi. Now, those are our parent functions, okay? That's kind of the base. That's what we start with. However, I am probably going to ask you to graph equations that are not the parent function, okay? Yeah, we need to know the parent function, but we also need to know how to transform it, okay? So let's go back to our knowledge from chapter 1 and mesh it with these 2 vocabulary words to figure out how to pick out the information from our equations and how it affects our graph. All right? So what I want you to do is I want you to write down one or both of these. Okay? Y equals A sine of the quantity bx minus c plus d. These are all the possibilities of ways our graphs could be affected by stretches, shrinks, and shifts. And I'm going to give you about a minute to talk amongst your pods. Please don't write anything down, but just talk amongst your pods and try to remember what A, B, C, and D all do to our graphs. Okay? Just a rough idea. Can we remember what would A, B, C, and D do to any graph? Okay? 1 minute. Oh, yeah, you're on. So think about it in your head. Okay. So like if you're subtracting, you're still right. Yeah. Well, does that work? Well, when he had it. Well, there's lots of things that okay, A. That number outside of our function, what does it do?
It's a vertical string.
A vertical stretch or shrink. What did we talk about that was related to the vertical size? The 2 words that we just wrote down. The amplitude. So A is going to affect your amplitude. Whatever the absolute value of A is, that's your amplitude. Okay? Now, I say absolute value because amplitude is a distance, so it's always positive, but it's possible that A is negative. So first we look at the absolute value, and that tells us our amplitude. But if A is negative, we know that we're going to have a reflected graph. So that's something to consider. We don't just ignore the negative. The negative does tell us if we have a reflection or not. Okay. That should be the easiest thing to pick out. What's the amplitude? All right. Now B. B is multiplied inside of our function. So B affects our graph how? Horizontally, a shift or a stretch?
Stretch.
Okay. B is going to be some sort of horizontal stretch or shrink. Well, horizontally, we talk about the period of our graph. So B is going to help us determine what the period is. Now, since our parent graph has a period of 2 pi, we're going to base everything off of that. Okay, so if you have a coefficient that's not 1, you're going to take 2 pi over b, and that's going to be your new period. All right, now C and D. Eli, how do C and D affect our graph?
C is how to be translated left to right.
Okay.
Then D's y intercept.
Okay, so we have horizontal shift, vertical shift. Okay. Now, technically, our horizontal shift isn't just C. Okay. If you recall back in chapter 1, if there's a coefficient to x, it does affect this number right here. We did some problems where we had to factor that number out so we would know whether we had a left or right shift of whatever kind. So for our shifts, what I'm going to have you do, we're going to identify what I call the starting point. Okay? We're going to graph using the framing method on Monday. And the starting point is going to tell us where to start our frame. Okay, so if we take C over B comma D, that'll tell us where to start our frame. Now keep in mind, this is BX minus C. Okay, so if it's subtraction, we're moving to the right. If it's addition, we're moving to the left, so we'll just have to keep that in mind when we identify. Okay? So your job today with any problem that I give you, whether it be up on the board or in your homework, is going to be to identify amplitude, period, and starting point. If we can do those things, then Monday I can show you how to graph by framing, and we can use those 3 pieces of information to draw a frame and sketch in our curve. Okay? So, we will start off simple. Please write down example 1. Y equals 4 sine of x. Four. Veronica, what is 4 times? All right. Our amplitude is 4. Okay. Do you see a B? I don't see a B. Technically, B is 1. The coefficient of x is 1, which means our period is going to stay as 2 pi. There's no stretch or shrink to affect that. So if the coefficient of x is 1, your period can stay as 2 pi. All right? And then our starting point, I'm just going to call it SP so I don't have to write out all of those other letters. Starting point. Okay? I don't see a C or a D. All right? So if there is no shift, we just keep our starting point at 0, 0. All right, let's up the game a little bit. Y equals -3 cosine of 2x. Reckon what would our amplitude be?
3.
Good. So A is -3, but amplitude needs to be positive, Okay, so she told me the amplitude is a positive 3. But I would make a note to myself that this is going to be a reflected graph so that when I go back to graph it, I remember that instead of maybe the valley, I'm going to have to flip it and it's going to look like a hill. And we'll talk more about that on Monday. Okay. The period. It looks like our B value is 2. Okay, so Kelly, how would we calculate the period? Read that again, 2 pi what? Yeah. Very good. So we take 2 pi and we divide it by B. Since B is 2, we'll throw it there. And so our period is length pi. Once again, we don't have a C or a D added or subtracted, so our starting point can remain at 0, 0. Yes?
What's that, like, equation for period, like, when you're looking for it? Because I just don't know where to get the...
Yep. So period is 2 pi divided by B.
Okay.
So since B is 2, we wrote 2 pi divided by 2 to get pi.
All right.
All right. Can we round up a little bit more? Like maybe throw some C's and D's in there? All right. Example number 3. This has got it all, doesn't it? What's our amplitude? Our amplitude is 2. Okay? A is 2, so our amplitude is 2. Okay? Mia, how do we calculate the period? All right, so we're going to take 2 pi divided by B, and since B is 2, we're going to take 2 pi divided by 2. So our period is pi. Now, for our starting point. For the starting point. Madeline, what did we write down for our starting point, like in general?
C over B and then D.
C over B, comma D. So, our C value right here is pi over 3. So we are going to have to take pi over 3 and divide it by our B value of 2. And then our D is just whatever at the end, right? That negative 2. Yes? I expect you to do that, yes. So then our last step would be to actually do this division. I never want a fraction in a fraction. So pi over 3 divided by 2, if you'd like to think of this as multiplying by the reciprocal, this is pi over 3 times 1/2. So we get pi over 6 negative 2. I'm going to give you 1 minute to work together to come up with the amplitude, period, and starting point for this. We'll go through it together, and then we'll be done. Okay, so you try it first. Then we'll work together to make sure that we're on the same page. And then I'll give you your quizzes back and instructions. Oh, no. So since it's EX minus C, this is a pi because we want to shift to the right, so it should be positive. But this is shift to the left. We want that to be negative. I had a good question that I'm going to talk about before we go through this. Back up here on example 3, do you notice how this was 2x minus pi over 3? Okay, well think about our shifts. We know that this is a shift to the right, and so it makes sense that our starting point has a positive x. All right? What sort of shift do we have here, right or left? This is a left shift. Okay, so we'll talk about that when we get there. Okay? Amplitude. Taylor, what do you have for your amplitude? All right, good. A is -1, so our amplitude is 1, and we'll just have to remember that this is a reflected graph. Amplitude is always positive. All right. The period. Okay. Ryan, what do you have for the period? 4 pi. Our b value is 1/2. So when we take 2 pi divided by b, we end up with 4 pi. 2 pi divided by 1/2 is the same thing as taking 2 pi multiplied by the reciprocal, 2/1. Okay? So then for our starting point, c over b, comma d. C over b, comma d. Emma, what did you get for your starting point? -pi/2, 3. So our c value, we need to call it a -pi/4 because it's a shift to the left. We have to divide that by our b value of 1/2, and then our d value is 3. So -pi/2, comma 3 is what that reduces down to. Remember, when you're dividing fractions, it's this, you take the numerator and you multiply by the reciprocal of the denominator. If you actually need to write that work out, that's fine. Some of us can do it in our head, and that's great too. Whatever works for you. All right, so your homework is going to be fairly short. Okay. All you're doing is identifying amplitude, period. I don't think the book calls it starting point, but go ahead in your homework, identify the starting point. Okay? So that when we come to our time together Monday, you remember what we're doing. Okay? Let me stop this.